Hi, I am Chanchekar Gupta and we are discussing programming concepts. In the last video, we have discussed about trees. In this video, we are going to discuss the different possible ways in traversing a tree and listing out what are all the elements or the data existing in that present tree. Let's have a look. This is a tree, and for any tree, we are having in-order traversal, pre-order traversal, post-order traversal and also level order traversal. In the case of in-order traversal, the top node is called root, this is left node and this is right node. It should start with left, root and then right. Pre-order traversal starts with root, left, right. Post-order travels with left, right and root. In all these things, only the position of root changes. In the pre-order traversal, it starts at the first position. In the in-order traversal, it moves to the second, and in post, it moves to the last position finally. So, if you are having a pre-order traversal of 1, 2, 3, as it has started with root, 1 is the root of this entire tree. If you have the post-order traversal of 3, 1, 2, as it is ending with the root, 2 is the root of this entire tree. If you want to write in-order traversal for this tree, it starts with left, root and right. 2, 1, 3. Similarly, pre-order traversal 1, 2, 3. Let's also write post-order traversal. Left, right and root. So, 2, 3, 1 respectively. If someone asks you about converse orders like converse in order, converse pre-order, converse post-order, you can just interchange the position of left and right and everything will be the same. And the level order traversal is to list in levels. This is level 0, level 1. So, it is 1, 2, 3. If you have more levels, you will just continue this process. In this case, as we are having only 3 nodes, we have written all these traversals very easily. But how do we write all this traversal mechanism when we are having more number of nodes? Let's try to discuss it with the help of an example. Before discussing it, I want to introduce you to a term BST, which is called as binary search tree. There is a difference between binary tree and binary search tree. That is, if you take the root, all the elements which are less than the root will be present to the left. All the elements which are greater than root will be present to the right. This happens in the case of binary search tree, but in the case of a binary tree, you can insert it in any order. Let's try to build binary search tree with the help of the given example. Initially, my root is 50. So, I have started with 50, then 20. As 20 is less than 50, I have to insert it in the left side. 60 is greater than 50, it has to be inserted in the right side. Everything has to be compared with the root. Now, I am having 70. 70 is greater than 50. Now, 70 is also greater than 60. So, 70 will be inserted here. 25, less than 50, greater than 20. Similarly, 36. 50, 25, 36. 85, okay. 92. So, I am having 92 here. 65, greater than 50, greater than 60 but less than 70. So 65. This is the way you try to convert a sequence into binary search tree. There will be questions possible on this binary search tree asking whether the tree structure is valid or not. Then you have to check whether it has followed all the rules. Starting from the key, all the elements on the left side is less than the root element and all the elements in the right side are greater than the root element. If you want the least of the entire tree, you can just go to the last in the left side. So, this is the last element in the left side. So, 20 is the smallest element. Similarly, if you want the largest element, you have to go to the rightmost. This is the final and largest element. So, 92 is the largest element in this tree. This is the way in which binary search tree can be used, and it is very helpful when it comes in terms of search. Now, we will try to take a simple example and we will try to write all the tree traversals that we have discussed earlier. Is it a full binary tree? In the case of full binary tree, we are having 0 or 2 children for every node. But here, for this node, we are having only 1 child. So, it is not a full binary tree. Whether it is a complete binary tree, it has not been processed sequentially. If 20 was on the left side, it would have been a complete binary tree. But in this case, as it is not filled in sequence and it is not complete, it is not a complete binary tree. Whether this is a perfect binary tree, in the case of perfect binary tree, we are having 2 conditions. First one, all internal nodes should have 2 children. All leaves should be at the same level. But here, all these leaves are at the same level, but this is not having 2 children. So, it is not even a perfect binary tree. In this way, you will try to identify whether it is full, complete or perfect binary tree. Let's come back to the point of tree traversals. The first and foremost step in tree traversal is make 2 branches for every node. Why I have made this is, if we have a node, let's say A is a node and it is having 2 branches. Now, I need to perform traversal on A such that I will perform it top down and left to right. In this mechanism, when I first visit A, I'll include it in pre-order traversal first time, and when I visit it second time over here, I'll include it in order traversal. Similarly, when I finally see A and I'm leaving this node for the third time, I'll include it in post order traversal. This is an easy approach in which you can build pre, in and post order traversals easily. Let's try to apply the same approach to this tree and let's solve it for these three traversals. Let me write pre-order traversal. If you remember, pre-order traversal has to be written when I visit the node for the first time. So I have to visit it top down and I have to visit it left to right. I'll start from here. So I visit 10 for the first time, 10, and then I'm visiting 9, and I'm visiting 8, and then I'm visiting 8 for the second time. I'll leave it for now because in the case of pre-order traversal, only when I visit for the first time it matters. Now I'm visiting 9, 6 I have visited here for the first time. So 6 I'll write, 15, here I have not visited anything. Now I have visited 20 over here, and it ends. This is the pre-order traversal for this tree. Let's try to write in-order traversal for the same tree. In-order traversal should be written when we visit the node for the second time. So I have to start from top down to left to right. I have not visited any node for the second time yet. Here I am visiting 8 for the second time. 8 has to be written. And then I am visiting 9 for the second time. 6, 10, 15, 20, and that's it. In a similar way, let's try to write post order traversal. I have to visit it top down, left to right. Now I have to make a node when I visit the node for the third time. First time, now I am visiting the node 8 for the third time. So I'll try to write it 6, 9, 20, 15, 10. If we just observe, these are the tree traversals for this tree. If you want level order traversal, 10, 9, 15, 8, 6, 20. Now we have seen how to write pre, post and in order traversal for a particular tree. But if we have pre, post and in order traversals which are given, can we uniquely identify a tree? Can we form the tree with the help of the combinations of these traversals? How can we do that? Think about it. Stay tuned to find out.